Okay, thank you so much. This is a call. I'm coming here also to do this number. This number is the physics, so I'm going to solve it. And you can see the question right here. It's saying the number of particles dn open bracket v with impact parameter between v and v plus dv is the flux multiplied by the area between two concentric circles of radius v and v plus dv. Now we are going to drive, dn open bracket theta is equal to f phi times d naught squared divided by 4 open bracket cosine of theta divided by 2 divided by sine raised to power 3. Then we have also an angle theta divided by 2. So you have to know that this is the angles as cos and sines are a function of trigonometry. And I'm going to drive this equation so that it comes exactly like this. When you see this equation here, so you can see that this one is a flux, of nucleus. And if this one is a flux, then we are going to say from our d node we have 2 phi f b dB. When you check here, this one is a column force. The F we are seeing inside here is a column force. And we also know that V is equal to D naught divided by 2 cotangent of theta divided by 2. So this is our impact parameter. And then this impact parameter will be the one now we have to generate so that it gives us dV. And then when we need to do that, we have to differentiate this quantity here so that we have dV, because we don't have dV. This is what we are going to do now. For us to derive dV, we are going to say the derivative of V, we are going to say dV with respect to d theta. With respect to d theta is going to be, we are going to apply the quotient of the two functions, because we have here cotangent is a function which is stated that cot is equal to sine divided by, it's equal to cos divided by sine. And when we are going to make it as a quotient of the two functions, we are going to have we're going to factorize out d theta divided by 2 outside the bracket. And then we are going to say, when we drive this, we have a coefficient which is 1 over 2. When you drive the function, the trigonometric functions, always the angles will move to the other side, the coefficient of the angle. So the coefficient of the angle we say is minus 1 divided by 2. This is the coefficient of the angle. Or you say plus, there is no problem. Then we can say the rules of quotient rule say that don't drive v, but drive u. So we say we have to write sine here into the derivative of this is going to be sine, and then we make bracket minus cosine into minus cosine, and you make it like that. And make sure that we are maintaining the angles, which is theta divided by 2. Make sure it is here. So I didn't put it because it will make our number to be very big, and then you will panic that there is big thing happening. All this one is by sine, which is v sine v square. Sine squared. Let's say let's put the angles. You can put the angle even here. The angles is there, but there's no problem. When we are going to do this, we are going to say dv with respect to d theta is going to be d. When we multiply this one, we are going to have d theta. Here is minus. Then we have 4. Then here is sine squared. Let's say 2 theta plus sine, plus cos squared theta divided by 2, all by sine squared theta. 2 theta over 2. That is it. And then when we are going to make dv to be one of the subjects, we are going to say dv is equal to d theta divided by 4. And then here we have minus sine And then when we say sines and cos, this one is 1 in our Pythagoras theorem. So this one and this one is 1. So we are going to say 1 divided by sine squared, theta all over 2. And then we have here d theta. Okay. Now you see we are going to flux all the variables. I mean we are going to flux all the quantities. We're going to plug this one, and we are going to plug this one here into our what? Into our formula. And then when we are going to say that is now dn, then we say dn with our phi is going to be, we write 2. Let's say you begin with f, or you say anything is also okay. 2 phi f, and then you open bracket, you put the value of v, I mean, that is d theta over 2, and then cotangent is going to be sine, I mean it's going to be cos theta 2 all over sine theta all over 2. I think then we put this one, which is dv. So we are going to put here dv, which is d theta all over 4, and here is minus, and then 1 divided by sine raised to power 2, and then theta all over 2. Okay, I want to run this side so that we do our number. And sorry. And then when we plug all this thing here into our number, we are going to have, you can see that 2 and these 2 will go. So we remain with this. Let's say d theta times d theta, we are going to have d theta squared. Let's say dn with respect to theta here is going to be 2, I mean, it's going to be phi f or f phi here. And then when we multiply d theta times d theta, we are going to have d theta squared. And then 4, we have 4 down here. This one is minus 4, and then sine times this sine. Sine here is squared, and this one is 1. So we are going to have cos theta over 2 divided by what? Divided by sine power 3 theta divided by 2. So, and when you compare it with our values here, you can see that the match. So that is how you can drive the plug, the column force, and the relation between column force and B, that is impact parameter. And this is now how we drive the formula. So thank you so much. And when you check, you can see that they have reconciled themselves. Content like this, you need to